For the last part of this problem, we're asked to find the current at resistor 3. And so we can go right back to Ohm's law once again. So we can say V sub 3 equals I sub 3 times R sub 3. And since I'm looking for I, I want to isolate that variable. So since it's being multiplied by R, I divide both sides by R. These R's cancel out. So now I have V sub 3 divided by R sub 3 equals I sub 3. And my voltage at resistor 3 we found before equals 0.4 amps. My resistance at resistor 3 is equal to 3 ohms. So 0.4 divided by 3 equals 0.13 amps. And that's my current at resistor 3. Now I've completed all the long parts of this problem. And if you have your whole paper in front of you, you're able to do a few checks. So before, we thought about our resistance total. And when we did that, we were looking at this as resistor 2, 3 in series with resistor 1. And we said that our total current was equal to the current at resistor 1, which was plus not plus, which is also equal to the current at resistor 2, 3. And so my total current, which is 0.52 amps, would be equal to my current at resistor 1, and we found both of these things up here, 0.52 amps. And that should also equal my current of resistor 2, 3. So that's according to my series rules. So now if I look, since resistors 2 and 3 are in parallel, the current of resistors in parallel, so I'm going to say I23 is equal to the current in resistor 2 plus the current in resistor 3. So I can say I23 is equal to the current in resistor 2, which we found before, 0.4 amps, plus current in resistor 3, which we just found down here, so 0.13 amps, and that gives me 0.53 amps. And since that number is very close to my number up here, and I think the difference was just a rounding of a decimal early on, I know that I've probably solved this problem correctly. This is a good check for me to do at the end of my problem.